Hey there, I'm Simon, a creative UX engineer out of Orlando, Florida. In this quick tip, we're going to get set up using WebGL shaders with Vue in a reactive way. I won't be touching too much on how to build a WebGL shader or anything like that, but I'll show you a quick tip that you might find useful if you're already doing something along those lines. So here's a quick example. This blue boundary, this blue border, is a simple canvas element. Inside of there, we have a WebGL context where we're rendering a yellow circle just using a fragment shader, right? Below that is a standard HTML input, a type range, which draws a slider to the screen. And if I drag the slider, you'll notice the yellow circle changes its radius. It's simple, right? Simple connection between reactive data coming from the slider into a WebGL shader and making the circle change size. So let's take a look and see how this is done and the tip that I want you to take away from this. This is the fragment shader source. Now, I'm not going to explain this, A, because I don't have the time on this short tip, and B, because I don't have the brains to understand what's happening half the time. But I do want you to focus on this, and that is the uniform that we declared at the beginning of the file. You can see here we're adding a uniform, a float value for u_radius or uniform_radius. And what a uniform is in WebGL is like a global variable that allows JavaScript to pass data from JavaScript into the GPU, into the WebGL context. So that's really all you need to know. Just keep that in mind here for 1 second. Jumping into our Vue template, we have a canvas, which is just a regular canvas. And we have our input type range that we saw a couple of seconds ago. And you'll notice it has a V model for radius. In our script setup tag down here, again, you'll notice radius lines up. So we have a radius there, and we have our input type range using the radius. Now let's take a look at this init WebGL method, which I've got set up. It's inside of onMountain, so that we already run it on the client. And let's go ahead and jump on into that. Now, again, not going to be jumping in too far as to how we create a WebGL, compile it and create a WebGL program. What I want you to pay attention to here is sort of the sister method to uniforms that we just discussed, and that is the location. So if uniform is a global variable inside of your GPU, right, inside of your WebGL context, then a location is simply saying, hey, where in GPU memory is u_radius, right? How do I get that? How do I change it? And so what you do is you say, hey, let me get the radius location, right? The u_radius's location in the GPU memory. And then every time you go to draw, you would simply update radius location with the value that you want to pass in. In this case, it's our radius.value. And it's .value because we're using Composition API, a reactive ref. We want to use the .value notation to get the actual 0.5 value out of that. And that's it. At this point, you're probably looking at me going, Simon, that's stupid. Why did we need reactivity to do this? It's just an extra layer of complexity when we could have used plain old JavaScript. And you're right, except what would you do next? What would be your next step? You've already got a draw function in there. You're calling it once at the initialization. But what's next? Well, I'd say for me, the answer would be to set up a request animation frame loop, right? You want to run draw multiple times so that it animates every time. But in this example, in the yellow circle example, it doesn't make sense because the yellow circle doesn't need to change every single frame. It only changes when the radius changes. That's where reactivity comes in. Yes, this is just a simple performance tip. If you watch radius and only draw when the radius changes, you will be able to animate this yellow circle to change whenever this value changes. But the second I let go and the second I'm not changing the data anymore, this is now just a static image. It's not running the draw loop again until I touch that input slider. And obviously, you could take this and expand upon it. You could watch multiple variables like radius, an X position or Y position. You could pass in reactive mouse data if you're using, like, let's say the Vue use library, which has mouse information and all this other sensor information. You could pass that all in as input and only render again when those, sensor information changes. Or you could, let's say the whole thing's moving all the time. Right? This WebGL shader was constantly changing, and so we couldn't pause rendering. You might still want to, let's say, disable it when the window loses focus. Or if this canvas was to move in and out of the viewport, you might want to stop rendering so it's not rendering when it's, not visible on the page. It's not calling that draw loop. So simple tip mostly comes back to performance, but I thought it was interesting to see just how you could combine reactivity with a WebGL shader and just hopefully improve some of your online experiences. So thanks for watching. Hope it was useful, and I will talk to you soon.